In the first version, let me call this as AA, $AA. It receives one of the character from the device identified by the identifier 04. If I have one of the macro within another macro, then it is called as a nested macros. All these operations are repeatedly carried out in case of expanded version of the source code. Hello everyone, it is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, let me take you into the details of the second version of PUTC macro definition. In the previous sessions, I was discussing about the macro expansion and the drawback of the first version of macro expansion overcome the drawbacks of the first version of macro PUTC message expansion, then how they encountered with problems in second version of macro expansion and what is the problem they encountered and how they overcome the problems of second version of macro expansion and what is the solution they found for the final version of macro expansion. So totally we are going to complete the details of macro expansion in today's session. That is, the problems with the second version of macro expansion is going to be discussed first. Later, how these problems of second version of macro expansion has been overcome in the final version of macro expansion is going to be discussed now. In this problems of this, you have seen that suppose if there are labels or any symbols which is generated at the time of pre-processing or during the time of macro expansion just before the actual compilation begins, then we must have certain specific unique symbols to identify the statements in the expanded version of the source code. If that is the case, let me tell you that we have ampersand AA within the first macro expansion. That is, when the macro definition is invoked for the first time, we will invoke those statements with this kind of label, that is $AA. That means, suppose I have a program like this. I have a looping statements like this. Let me write down in higher level languages like C. For I is equal to 1 to 10. This is in MATLAB. I am going to tell you that. Let me have the set of statements following this. Then I have an end of the looping statement. Here, initially I am initializing this variable I to value 1 and it is incremented by 1 every time the statements are executed. That means once when the statement is executed, it is incremented by 1. Next time I becomes equal to 2, then so on and so forth till it becomes 10. So it executes for 1 to 10. 1 to 10 times. So totally 10 times these statements are executed. During the time of execution, if there is any call to the function definition, then obviously those function definitions must be placed in place of this loop. That is, if I have one more function definition called addition, I have a function definition here. This is a main function. This is in main function. For loop is in main function. So let me write down a set of statements here. At last, it returns some value to the function definition where it is called addition. Right? Now we have this return statement here. What is the value going to be returned here? Integer type of data is going to be returned. So I have a function header with return type. This is returned to this. Once when the function is invoked, this function definition is invoked and it is placed in place of macro. Similarly, the same functionality is applied during the time of compilation. But before the actual compilation begins, the macro expansion must begin. So how the macro expansion gets called? All these three statements are placed in place of this. So the expanded version of the source code will be for I is equal to 1 to 10. We have this statement addition here, 1, 2, 3. Addition, again I have addition. In place of this addition, I will replace this addition by these three set of statements. Then again I will have end statement here, one more statement here. Then again, once when the I is incremented by 1, it becomes 2. So again I will have three more statements, that is this, then one statement. So we have the looping statements like this. This is eliminated and the entire thing is placed in place of this. So we have once here, twice here, thrice here, fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, 10th time. So this is the actual statement that gets placed in place of this location. Because I am going to call this addition 10 times, that is from I is equal to 1 to 10 within a loop. So instead of calling it repeatedly, I will place this function definition in place of function call 10 times so that it gets expanded. So this is removed from here. Now I have an expanded version of the source code. In the first version, let me call this as AA, $AA. This as $AB. This as $AC. This as AD, $AE, $AF. So until AZ. Similarly, if there are few more things to be represented, then it is called with $A0, $A1, $A2, so until $A9. Then the actual label begins with BA, $BB, $BC, so until $BZ, next $B0, so until $B9. So this process continues. Then we have $CA, so on like that. This process is going to be used for the expanded version of that. So we have like this kind of operation. So dollar is the system qualifier. Dollar is the system qualifier is advanced for each macro expansion. That is, for each macro expansion, dollar is the system qualifier going to be used, whether or not the expansion makes use of it. Then, similarly, let me consider the macro definition of PUTC message, which is even better. Now, I have a PUTC name of the macro. Then we have the two parameters. The first parameter is the character which needs to be printed. Then we have the device from where the character is to be read or received. Then we have store accumulator here. We have $save here. Then we have load character LDCH ampersand character here J. We have the looping statement here. Where does the looping label lies in this program? Looping label lies here. So again, a system qualifier we have, that is dollar here, similar to the looping statement which you observed in this case. You have the looping statement here. So we have the looping statement here. We have the very first word, reserved word, then we have TD, then ampersand device we have. Jump if equal. If it is equal, jump to this statement. Again, from here to here, it jumps here, and this statement receives the input from this device. Again, it comes back. If it is equal, again goes back to this statement and receives the statement. So we have repeatedly been receiving the statement for 10 times until this condition is satisfied. JEQ is equal. Once when it is not equal, we'll come out of the looping statement and then we execute this statement. LDA, save, and let it prints the value. This is how we are going to do the task of execution of looping statements in C language or in any of the languages, or in maybe in case of this assembly level programming language. So let me consider that this time if 4 prior macro expansions have occurred, then not necessarily to put C and not necessarily using the dollar system qualifier. The dollar system qualifier has been advanced through AA, AB, AC, AD. So we have the expansion code like this. So we have the expanded version like this $AA, AB, AC, so on up to AZ, then A0, A1, A2, so on up to A9. Then we have BA, $BA, BB, BC, BD, so on up to BZ, then B0, B1, B2, so on up to B9. Then the alphabet comes character. Next is C. So CA, CB, CC, CD, CE, CF, CG, so on up to CZ. Then we have C0, C1, C2, C3, C4, so on up to C9. So this continues to identify each and every expanded version of the source code. So with this, we will be able to recognize each and every statement uniquely in the expanded version of the source program. So let me take you into the final version of that. In the final version, they have PUTC here, which is a macro name. Then we have line comma X, which is that X is the character, 4 is the device identified by the identifier. Then we have $AE we have here, store in the store accumulator. Then we have a load character. We are going to load the character into this. Once it is stored into the accumulator, we are going to load it into the X. Then AE loop. Where do we have the AE loop here? Here I have a AE loop here. Then when it comes to this statement, it receives one of the character from the device identified by the identifier 04. Then the AE loop, this is going to be transferred to this statement again. Now if it is equal, it is invoked once again, that is the next character is read, that is B. Then the next character is going to be read dot, then the next character is going to be read C, then the next character is going to be read, then there is no character to read from this device, so it comes out of the loop and then it prints this statement STA last. So we have identified this with AA, this with AB, this with $AC, this with $AD. Now we have the expanded version of the macro, which gets its own system qualifiers, whether or not it uses the dollar system. Now, there is no reason that the macro facility cannot successfully process a macro call within a macro. For example, if I have one of the macro within another macro, then it is called as a nested macros, similar to the incorporation of one for loop within another for loop, one if statement within another if statement. We have one macro within another macro. So in this case, we have PUTC message. This is the name of the macro. PUTC is another name of the macro. We have the looping statement here, label here. We have a label here. Then we have, this is one of the PUTC message is the name of the macro. Within macro, I have one more macro called PUTC. Then I am going to execute these statements, these set of statements repetitively. That is, the message is going to be printed from the device, which is received from this device. The message is going to be printed. Then finally, when the value becomes greater than or equal to this condition, it comes out of the loop and starts executing these statements and prints it. These set of statements are executed. So we have this. The put message and the PUTC macro, for that matter, generates code that first saves the system state by saving the registers it works with, then restores the system state upon exit. What is the meaning of this? Suppose if I have one of the function calls within another function call, then how it can process that? Suppose if I have addition is the name of the function. Within this addition, I have one more functionality called factorial. I have one function definition. Within this function definition, I have another function call here. Is it possible to place? Yes, of course it is possible. This is called as a nested functions. Once when the function is invoked, it implicitly invokes the function which is defined inside another function. So what happens? So suppose if you have any parameters like this, one of the parameter, second parameter like this is going to be pushed into the stack, onto the stack, that is in the reverse order. These are read from right to left. So the second parameter is pushed, then first parameter, then zeroth parameter. Once when it returns certain value, it is going to use the second parameter, first parameter, second parameter, third parameter. Then it returns the computed result to this section. Then finally the next statements are executed. Then the statements of this addition statements are functions are executed. Then finally it returns its own function values here to the main function, So what is that happening there? We have one of the functions called main function. Main function is invoking the addition function in turn invoking the factorial function. So factorial function is invoked and it returns certain value. Once when it returns certain value, the return statement of addition is going to return to the main function. So main function is going to execute or finalize the execution of all these function calls. So what is that happening there? Implicit call, nested call is going to happen in the same manner. By saving the registers, it works with, then it restores the system state upon exit. How? By returning certain values. It unfolds the values which is returned from the function definitions. This is how it is going to be done. Strictly speaking, it is not necessary, but it is advisable, since the whole idea of using macros is to save the programmer's work. So it is advisable to place the whole idea of using macros to save the programmer's work. Next, what is that you have observed here from the first version of PUTC macro, then the problems with first version of PUTC macro, and how they overcome the problems of first version of macro in second version, and what is the problem with second version of macro, and how they overcome the problems of second version of macro in the final version of macro. All those are certain details which needs to be considered here. So the value of the $symbol qualifier for a PUTC message macro expansion is resumed after the PUTC expansion contained within it is completed. That is, one function definition defined inside another function definition. So we have the function call, which I explained now, the function call defined inside another function definition. So we have the unfolding of the information furnished by incorporating one of the function call inside another function call. So this means that if PUTC message is used twice in succession by a programmer, then if the first expansion, the $system qualifier as the value $AC in the first version of this, then the second call would be AE, because we have the function call within a function call put message. I have PUTC function here. So once when it's unfolded, this becomes $AC, this becomes $AE. Again, if it is invoked, this becomes PUTC message becomes put message becomes $AE. Then PUTC becomes $AF. So this process will go on like this. So we have the system qualifiers according to that. Suppose if I have one more PUTC, put yes here, then it becomes $AD. This becomes $AD. This becomes $AE. This becomes AF. This becomes G. Put yes becomes $AH. So each one of the function definitions in the macro expansion is identified uniquely, so that there would not be a problem during the time of compilation. Ultimately, we are going to find out a solution, and we are going to identify each one of these function calls, each one of these macro function calls in the expanded version of the source code uniquely. That is the only objective, that is the only intuition which we add at the earlier stages of the macro expansion, which we have achieved in the final version of the macro expansion. So, dear students, kindly observe that we have the code fragment, that is jump if equal. We are going to next, where it is going to next. PUTC message, we have CCOP, this, we have this message length like this. So once when the function is invoked within another function, the function invoked is to be identified with a unique label that is going to be used in the macro expanded version of the source code. So we have the example of PUTC message, assuming that 4 prior macro expansions have occurred before the macro facility encounters this code fragment. So the $system qualifier is at $AE. As I have already shown you here, this is called as AE because I have a PUTC message here, put MSG. Within that I have PUTC. Again, if it is invoked 3 times, what happens in the expanded version? Again, I will get put message, PUTC, put message, PUTC. So each one of these must be identified with some unique characters. So let me call this as $AC. This becomes $AD. This becomes $AE. this becomes $AF, this becomes $AG, this becomes $AH. So this is how it is going to be invoked. The same thing is explained here. This is $AE. Then the expansion will be like this. So if you look at this, you will clearly understand that how it is going to use that. $AF save, $AF loop, $AF loop, $AF save. Where is that AF loop here? It is here. Where is that AF save? It is here. Where is that AE loop here? We have here. So in each of these, you are observing that there is a dollar symbol which indicates that the macro facility has to be smart enough to not expand the dollar a second time. Once when the dollar is encountered, it indicates that that is a system qualifier. So it is not going to use this dollar symbol in the second time. But we have AF here, AF here. So AE here, AE here, AE here. So this indicates that each one of these statements in the expanded version of the source code are going to be identified uniquely so that the compilation will go on successfully according to the information furnished in the expanded version of the source code. So conditional assembly. Let us see to the conditional assembly. What is the meaning of conditional assembly? As you all know that, dear students, we have the conditional assembly with if statement in C programming language, or maybe an if-else statement, or maybe a nested if statement, or maybe an else-if ladder. We have, in all these cases, we have these kind of statements, conditional statements. Similarly, we have the conditional statements like this, while and end of while. We have go-to statements here. These constructs are going to be used for specific purposes. If the condition is satisfied, immediately the statement that follows the if condition is to be executed. Else, the statement that follows the else condition is going to be executed. Similarly, we have a while loop here. Within a while loop, we have the set of statements which needs to be executed, that is looping operations is to be carried out. Goto is a label that shifts the control from one of the statement to another statement. So there is a shift of control from one statement to the label where it is defined. So we have this. Again, we have certain conditions like EQ. This corresponds to equal. NE corresponds to not equal. Then we have less than LT. We have less than or equal to symbol like this. This is same as this. We will not use these symbols here in assembly level language. We use these symbols. EQ, not equal, less than or equal to, greater than or equal to. These symbols are going to be used in the assembly level language. So, and the logical operations like and, or, not with the using usual parenthesis grouping. So we are going to use all these kind of conditional statements for conditioning any statements to be executed. Then we have the logical operations, and the corresponding operators like and, or, and not are available with this. Then we have conditional assembly. Additionally, since the macro facility is essentially a text processor, it is necessary to provide at least rudimentary string processing capabilities, including system functions, for example, working with comma separated list. Please observe this carefully, dear students. We have a percentage symbol here with n items. This indicates that number of items. Then the length of the characters, the length of a word. Then we have the substring. This indicates that the substring, the length of the substring. Then indexing, this, that is the message from 0, message from 2 is to be considered. So all these are certain type of information which works with this conditional assembly. That is in case of this. if statement, while loop, and go to. All these are certain set of statements that is going to use these kind of information, that is list. For list type of operation, we have percentage n items. We have the next parameter, input parameters like modulus, length. Then we have substring. Then we have this macro indexing operations. So on like this. So we have all these possibilities to work with string type of operations. If you look at this example, you will observe that the number of items, suppose if there are items like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, we have a list of items here. This corresponds to 0th position. This corresponds to 1st position. This corresponds to 2nd position. This corresponds to 3rd position. This corresponds to 4th position. So totally how many items are there in this list? 0 to 4. 0 to 4 corresponds to 5 items. This returns the total number of items present in it is 5. Then similarly, length. This takes one of the parameter, that is ampersand L, which gives the length of the text string. What is the length of the string? The string that is ABC, that is 1, 2, 3. 3 characters. How many? What is the length of that? That returns 3. The length of this. I have a substring. Within a substring, I have, let me consider 3 to 4. What is that substring? In case of this, let me have ampersand L 0 to 1, 0 comma 1. What happens? This becomes 0, this becomes 1. So it prints only 2 characters, that is AB. Substring of this. This is a substring of this string. ABC is a string. What is the substring of this? AB is a substring. So we have the values printed like this, AB. So similarly, indexing operation is also possible. L of 2, which gives the character at this position. Then we have the indexing like this. What is the message I have? DEF of 0. This returns D. DEF of 1, which returns E. DEF of 2 returns F. So similarly, we have in MATLAB and higher level languages, or in Python like this, DEF of 0 to 2, 0, 1, 2, which is less than 1. So we have 0 to 3. This prints DEF. So this is how we are going to have the indexing operations. Similar to the higher level languages, we have these options in case of assembly level language program. So if you look at this, we are using this conditional operations like this: if, else, and end if. So if this condition is satisfied, number of items is greater than 2, then we execute these set of statements. Otherwise, we will come to the else block and we execute these set of statements. So this is how the conditional execution is going to be carried out. Then, which has the expansion of this, that is this expansion of this. Please look at it. We have ST1 ampersand temp, RMO 2 1, LD corresponds to ampersand 2 ampersand temp. We have the qualifiers like this. Then it is going to be expanded in this version, that is swap area. We have S, T, we have this swap area. So similarly, the first macro call leads to S, T, that is the number of items present in it is 2, which is equal to 2. So similarly, which has the expansion like this, that is STA is equal to ampersand A $AA temp. So we have RMO with S, T. We have $AA temp, $AA next. If it is executed once again, this becomes $AB temp, $AB next. Then if it is executed once again, then it becomes $AC temp. Then if it is executed $AC next. All these operations are repeatedly carried out in case of expanded version of the source code. So this is how the macro expansions are carried out with uniquely identified labels. So these labels will help us to compile the set of statements which is given from the expanded version after the pre-processing, that is after the macro expansion. So dear students, kindly come back to me in the live sessions so that I can clarify if you have any questions with respect to the topic I discussed in today's session. So thank you very much.